All right, so I think I'm live now. Can someone in the chat confirm? Okay, let me wait for a minute. I don't see anything in the chat yet. Is something wrong? I don't see anyone. Oh, I am live. Why is nobody writing in the chat? Yes, but limited audience, yeah. Is my audio okay? Do you want me to increase the volume of the audio or is it fine? Ravi says hi, Akash says yes, you're live. Sohail says today the div is so bad hard. Yes, I can. Not hard actually. Like C was tricky, but there's a trick for doing that, which I'll tell you. Today the div is yeah fine. Fine. Audio is fine. That means okay. People are typing down. Okay. Hi. Hello. Okay. Cool. How many problems were you are able to solve? Let me know in the chat. I solved A, B, and C, and I almost solved E as well. Like it's a very easy problem. I don't know why it's an E problem. The only thing is that people are getting TLE. Even I got TLE, but the way to get around TLE is very easy. So I don't know like why it was so hard. Even for problem C, like I think I would have done it a lot sooner, but I just felt like there are more possible cases, and that's why I didn't submit. But then I like in the end I just thought that let me just try submitting this one. So then it says only one. Okay. Okay. Let me see. Okay, so if we see problem A had 10,000 submissions, so pretty easy. B had 7,000 submission, which is like lesser, I would say. Otherwise, it has like around 8,000. C has only 1,200 submissions. Okay, system testing is going on. It had around 1,600 submissions, as I think. So yeah, again, like C was hard compared to other problem. Okay, I think we can start now. I'll be solving problem A, B, C, and E. Problem D I haven't read yet. That's why I don't know. So let's start. Okay, cool. So problem A says that a queen is standing on an infinite plane with the Cartesian coordinate system on it. In one move, she can move to the diagonally adjacent point on the top right or the adjacent point on the left. So basically, in one move, she can either move in the diagonal direction or in the left direction. Okay. That is, if she's pointing at x, y, she can either move at x plus 1, y plus 1 or x minus 1, y. So basically, what they are saying is, if this is a Cartesian system and we are at this point right now, we can either move in the diagonal direction or we can move in the left direction. These are the only two directions possible. Okay. Now, Yugen initially stands at point AB and wants to move at point CD. Find the minimum number of moves she needs to make or declare that it is impossible. Okay. So let me just quickly go to my notes. And what do we really have? We have a Cartesian system. Okay. And right now we are standing at this point, let's say, which is A comma B. Let's say it instead of a comma b, let's say it x1 y1. Not visible. Oh, no, it's not visible. Seems to be some problem then. There is some issue. Just give me 1 minute. Not sure why this is happening. Should I add it again or what? Oh, now it's visible, I think. Yeah, okay, cool. Okay, so we are at this point, and let's say it is x1, y1. Instead of saying like a comma b, let's say it's x1, y1, and we want to move at some point, which is this. And let's say this is x2, y2. This is where we have to move. Okay, now, yeah, it's perfect. Okay. Now, the only two direction where we can move is either in the diagonal direction or in the left direction, which actually tells me, if you see, that there is no way I can actually go downwards, and there is no way I can actually go more than this position. I can only move in this area. That's all. If I'm at this point. Okay, and this was x1, y1. Okay, so what you have to do is, if you have to, let's say, move at this position, first you need to move diagonally. Move diagonally such that you come parallel to this point, which is this one. And how do you do that? So basically all you have to move is y2 minus y1. That is how much you have to move. When you moved y2 minus y1, you actually covered this distance. But now your point is at this position, so you also need to move this point this much as well. So you will update your x1 as x1 plus y2 minus y1. This will be your updated x1, y1. And now you need to move in the left direction. So all you have to do is move x1 minus x2. So basically first you moved y2 minus y1 so that you came parallel to the point, and then you moved x1 minus x2 so that you came to the point. And that's all you have to do. To figure out if the point lies either in this area, for that what you have to do is first check if the new point is downwards. Okay, how do you do that? If your y2 is actually less than y1, then your answer is minus 1. Okay, because then you can say it is downwards. Then if it is not downwards, first move this point to this point. Okay, and then just check if the new point is in the left direction. How do you check that? If your x1 is greater than x2. Basically, if x1 is less than x2, then answer becomes minus 1. Because this means that point will be on the right side and we cannot reach there. And that's all you have to do. Let me quickly show my code as well. Things will become much easier with that. Okay, so this is the code. I'll again draw that. Okay, so if this was our Cartesian system, and let's say we were at this position, which is x1, y1. First, and let's say we had to move this at this position. First, I'm just checking if my y2 is less than y1. If my y2 is less than y1, that means the point lies somewhere here, which is downwards. Okay, if that's the case, print minus 1. Otherwise, make my answer equals to y2 minus y1, which means I'm trying to reach at this position. Okay, add y2 minus y1, and since my point has been updated to this one, move my x also in that direction. Okay, and then just check if x2 is greater than x1. If x2 is greater than x1, that means the new point lies on the right side. So again print minus 1. Otherwise, just add it to the answer and then print the answer. That's all. I hope this is clear to everyone. Again, a pretty easy question. And yeah, that's pretty much it for this one. And let's move to the next question, which is Mix Master. This is an interesting problem, I would say. There are a couple of cases on this question. Okay. I hope problem A is clear to everyone. If yes, just print, can you just have a yes in the chat so that I know? And why is the audience so less? Why are there only 12 people joining today? And there's some issue with my board as well. I can see that. Not sure why that's happening. Okay, got it, got it. Now I know why that is happening. Okay. Okay, cool. Done A and B. Okay, cool. Let's move to problem B now. Now, problem B says that you are given an array A of length n. The score of A is the max of A1 plus A2, A2 plus A3, and so on. Find the minimum score of A if you are allowed to rearrange elements of A in any order. Note that you are not required to construct the array A that achieves the maximum score. The max of an array is the smallest non-negative integer that does not belong to the array. For instance, for 2 to 1, it's 0. So basically, max is nothing but the smallest value which is not present in the array. That is known as max. भैया प्रॉब्लम का इंट्यूशन ही क्लियर नहीं होता है खुद से. That will come with practice. Okay, you just need to keep practicing. There's nothing else that you can do for that. Okay, so how do we really solve this problem? Let's look at the very first test case. If you see, okay, so if you see for the very first test case, we have 0 and 0. Okay, if we have 0 and 0, there is no other way to arrange this, and the like your array, which is this array A1 plus A2, will actually become 0 itself. Okay, and since the set has 0, the smallest value which is not present is 1. Therefore, the answer is 1. Let's look at the next question. Next part. We have 0, 0, 1. 0, 0, 1. What are all the possible combinations of arranging this? Either we can have it 0, 0, 1, or we can have 0, 1, 0, or we can have 1, 0, 0. If we take 0, 0, 1, the new array becomes 0, 1. 0 plus 0 is 0, and 0 plus 1 is 1. Okay, similarly, for this you get 1 and 1, and for this you get 1 and 0. And if you see, max of this would be 2, max of this would be 0, max of this would be 2. Therefore, since the 0 is the smallest one out of these, 0 is the answer. Similarly, for the last one also, if you try to find, 1 is the answer. Now, how do we really solve this problem? Something that you need to see in this question is that, let me just remove this. Okay, cool. Okay, let's take the last case. Why is it that the answer for that is 1 instead of 0? So the case was 1, 0, 0, 0, 2, 0, 3, 0. Okay, why is it that the max of this array after converting comes out to be 1 instead of 0? Now, if you want in your updated array a 0 to be present, okay, then the only possible way for that would be when you have two consecutive zeros. Okay, because if you add these values, you will get a 0, and this 0 will be present in the final array. Okay, so the only way such that 0 is not present in the array is when you have, like 0 is present in the array is when you have two consecutive zeros. And if you have 0 present, then the max will be 1. So why is it that we could not rearrange this array in such a way that no two zeros were consecutive? Okay, so if you see, what is the count of zeros? We have 1, 2, 3, 4, 5 zeros. And what is the size of array? Size of array is 8. So if you see, let me just remove this. Let's make 8 blanks first. So we had 1, 2, 3, 4, 5, 6, 7, and 8. Now I'll try my best so that no two zeros are consecutive. So I'll have 1 0 here. Now I'll skip this position and have a 0 here. Again, I'll skip this position, have a 0 here. Skip this position, have a 0 here. Okay. Now if you see, I've already placed 4 zeros and I'm still left with 1 0, which I need to place either at this position or this or this or at this position. And if I place it at any of these positions, let's say I place it here, I will get a 0 from these two values in the final array. That is why there is no way you can actually get max equals to 0. So basically what you get with this is that, let me just switch to my notes. What you get with this is that if count of 0 is greater than n plus 1 by 2. Okay. If count is greater than n plus 1 by 2, okay, then 0 is present in the array. 0 is present in final array. Okay, this is the very first condition that you have got. Okay, now if count of 0 is less than n plus 1 by 2, less than equal to n plus 1 by 2, then our max is 0. But what about all the other cases? For example, okay, if you see the answer for 0, 0, 1 was 0. Why? Because count of 0 in this is 2, which is actually n is 3, so 3 plus 1 by 2 is actually 2 only, and since count of 0 is less than equal to 2, max is 0. Okay, now let's say that we know that max cannot be 0 because 0 is already present. Then the next best answer that we can get is 1. So what are all the cases when max will be 1? So the first thing is that since max is 1, we know that 0 was not the answer and 0 is already present in the final array, which means count of 0 is actually greater than n plus 1 by 2. Okay, now, so as we saw, we were arranging it something like this. Let's say this was the array and we've already arranged these numbers and we need to arrange 1 and 2. 1 and 2 are left. If you put 1 here, this 0 plus 1 will actually give you a 1 and your max will not be 1. How do I place this 1 in such a way that max will never be 1? The only possible way for doing this is if you actually place all the possible zeros first, okay, then you place a big number and then you write 1. So basically, first take all these values of zeros, okay, take all the zeros, okay, then have some big number, let's say any big number, one big number, and then in the end have all the ones. Through this, some of these two ones will be 2, some of this one and this big number will be something greater than 2 only, and through this we can ensure that there is no 1 present in the array, final array, and that is why max can be 1. Okay, but what if there is no such big numbers and only ones are present? Okay, for example, the array was this. Then, if this is the condition, then your answer will be 2. So basically, there were 3 conditions. Okay, if count of 0 is greater than n plus 1, or basically if count of 0 is less than equal to n plus 1 by 2, then your max is 0. Okay. After that, all you have to see is if a big number is present. If a big number is present, then max is 1. If a big number is not present, then max is 2. And that's it. How do I see if a big number is present? All I can do is just sort the entire array and then see the last element. If it is greater than 1, then answer is possible. For like answer will be 2. If it is, sorry, answer will be 1. If it is equal to 1, then answer will be 2. That's it. Alright, so I hope this is also clear to everyone. If yes, we can move forward to the next problem. Let me show the code as well. See, so these are the 3 conditions that I was talking about. First, I sorted the entire array. After that, I just take if my count of zeros is less than equal to n plus 1 by 2, then the answer is 0. Otherwise, I just take if a big number is present. So for that, since I've already sorted, the last value in the array will be the biggest number. So I'm just checking if it is not equal to 1, then the answer is 1. Otherwise, the answer is 2. That's it. Now, I would say this question was pretty good. There were 3 cases. If the only cases would have been 0 and 1, it would have been an easy question. But I'm pretty sure many problems forgot that the answer could be 2 as well. That is why I would say like this was a good question. Alright, so let me just look at the chat. Problem, okay. Important observation for the question is that the answer can be 0, 1 and 2. Yes, exactly, Chira. Okay, cool. Let's move to problem C, sequence master. Alright, so now this is a very good question, but there is a very good trick to solve this question through which you don't really have to waste any time. I'll tell you that trick also. Okay, like that is how I solved Even I was stuck at this question for a long time. Okay, so the question says that for some integer m, Yaquin considers an array cube of 2m integers good. So basically there is a value, there is an array cube which has 2m integers. Okay, if and only if, now this array is considered good if and only if every possible sequence, subsequence of cube of length m, the product of the m elements is equal to the sum of the elements which are not taken in the sequence. Okay, for example, I'll give you one example. Let's say a sequence had Q had 6 elements, which were A1, A2, or let's say 4 elements, A1, A2, A3, A4. What Yaquin, whatever that is, wants is that if you take any subsequence out of this of 2 elements, sum of those 2 elements should be equal to the product of the remaining 2 elements. Basically, if you take A1 and A2 as a sequence, A1 and A2 as a subsequence, then A1 plus A2 should be equal to A3 into A4. If you take A1, A3 as a sequence, then A1 plus A3 should be equal to A2 times A4. If you take A1 and A4 as a sequence, then A1, A4 should be equal to A2 times A3. Similarly, if you take A2, A3, then A2 plus A3 should be equal to A1 times A4. And if you take A2, A4, then A1 times A3. And if you take A3, A4, then sum of A3 plus A4 should be equal to A1 times A4. This is what the question is saying. Now, one easy observation is that one such array would be if you have all the values as 2, because 2 plus 2 is actually equal to 2 times 2. Or another way would be if you have every element as 0, because 0 plus 0 is actually equal to 0 times 0. So these are two very easy arrays which you can actually make. Okay, what about any remaining arrays? That is something we'll look, but before that, let's read the entire question. Define the distance between two arrays A and B, both of length k, to be summation of absolute difference between ai minus bi for all I from 1 to k. Okay, so you're given a positive integer n and an array p of 2n integers. So right now we have one array which is known as p and it has 2n integers. Okay, now find the minimum distance between p and q. So you are already given the p array. You need to construct a q array such that the difference between array p and q is minimum. That is all we have to do, and we are not required to print the array. We just need to find the minimum distance. That's it. So if you look at the very first case, if you see the very first case, which is 6 and 9. Okay, now since there are only two elements, 6 and 9, the only possible way, if you see, is either 6 and 6 or 9 and 9. Because if your entire sequence is 6 and 6, a subsequence will be take only one element, and since both the elements are same, it will be 6 only. So 6 is equal to 6. And similarly for 9 also, 9 will be equal to 9. Therefore, you can either have 6, 6 or 9, 9. Or you could have like 0, 0 also, or 3, 3 also. Everything is same. Okay, but since you have to find the minimum answer, the only two possible cases you can consider is 6, 6 or 9, 9. If you take 6, 6, difference between like both the arrays would actually come out to be 3, because if you have 6, 9 and your final array is 6, 6, this difference will be 0, this difference will be 3, and the total answer will be 3. So this is a pretty easy case if your size of the array is 2. What about when size of array is 4? What about when size of array is 4? Let me just delete this. Okay, again for this example, if you see, if you actually take the array 2, 2, 2 and 2 for this one, and the original array was 1, 2, 2, 1, the difference for this would be 1, for this will be 0, for this will be 0, for this will be 1. Summation of all these values will be 2, and that is the answer. But what about this case? If you try to do the same thing for this case, okay, so basically what you have is minus 2, minus 2, 2 and 2. And if you try to find the distance comes out to be 4, 4, 0 and 0, and sum of all these is 8. But answer is 5. How do we really find any other sequence which actually gives us a lesser value? Okay, now this is actually the entire thing that you have to figure out in the question. If you have figured this out, then the question is pretty easy. But how do we really find this answer? Now, if I tell you about my case, I actually tried many cases. I could not find, and I was almost on the verge of giving up. And then I just thought, why not write a brute force for this one? Why not write a brute force for n equals to 4? Try to see all the subsequences, all the sequences which will actually give me that sum of first half, like sum of n by 2 numbers is equals to the product of the remaining n by 2 numbers. And that is exactly what I did. I'll show that code as well. So basically what I did was, yeah, what I did was I just ran a nested for loop for 4 values a, b, c and d, a, b, c and d, such that this a, b, c, d is a sequence. Now I try to find if I take any subsequence of length 2, sum of those two values should be equal to the remaining two values, product of the remaining two values. And that is exactly what I wrote. If all these conditions were true, then I just printed the entire array. Okay, and after printing this array, I found this. 0, 0, 0 was something that we had already discovered. 2, 2, 2, 2 was also something that we had already discovered. But we didn't know about this case. This is also one possible condition. Because if you take these two values, let's say, sum of these two values is -2. And product of these two values is also -2. Or if you take it like this, -1, 2, -1, -1, sum of these two values is what? 1. And product of these two values is 1. So as you can see, this is also a possible case. And if you go back, to the third question and see for this input, for this input, we had -2, -2, 2 and 2. And if you try to find the answer using -1, -1, -1 and 2, difference of this comes out to be 1, difference of this is 1, difference of this is 3, difference of this is 0, and sum of all these values is 5. This is the missing case that we need to find out. Okay, so what about this value? How do we really find an answer for this one? To find an answer for this one, I need you to analyze the answer. Okay, so basically we had -1, -1, -1 and 2. What if n is 4? Like this was for n equals to 2. We had 4 values and this was the answer. What about n equals to 4? For n equals to 4, if you actually try to see, what we were really doing for this one was, sum of these two values was coming out to be 1. Product of these two values was also coming out to be 1. Upon some observation, you will see that for this one, when n equals to 4, the answer would be -1, -1, -1, -1, -1, -1, -1, 4. Sorry. 4. And if you see, product of these 4 values, sum of these 4 values is -4. Product of these 4 values is also -4. Product of these 4 values is 1. And sum of these 4 values is 1. And that is why through this we can say that every subsequence will be a good subsequence. Okay. This is one possible case for this one. And if you try to find the answer of this array with this one, the answer will come out to be 13 only. Yeah, 13 only. Okay. Now, basically, what all things do we have? Let me just analyze everything again. Okay. So, for any value, our answer will be -1, -1, -1, so on till n by 2. Okay. But what if n equals to 3? If n is equals to 3, then our array will have 6 elements. And if you try this one, -1, -1, -1, -1, -1, and then if you write 3, this doesn't really give you the right answer because sum of these 3 elements is -3. Product of these 3 elements is 3. So this case is not valid when n equals to 3. Or even for n equals to 6. Because for n equals to 6, sorry, not for n equals to 6, for n equals to, is there any other? 7. Then you have 14 elements. then also again you don't get the answer. So basically, for even ends, this condition is true. For odd ends, this condition is not true. That's all. Okay. So these are all the conditions that you had to figure out. And yeah, that's pretty much it. Let me just open up my code as well, and then I'll explain like how do you really write for this one. Okay. So I have just scanned the entire array here and then sorted it. Okay, because I also need to rearrange the array. Okay, so that my difference is minimum. Okay. Then if my n is equals to 2, I know the answer will be the difference of these two values, because we had 6 and 9. Either we can have a solution for 6 and 6, or we can have 9 and 9. Ultimately, the difference will be the difference between these two values. So I just printed out the answer and then continue. If that is not the case, then first I try to see, maybe my answer comes out from 0, 0, 0, if everything is 0. Okay, so this is what I've done. For example, like if I had any array A1, A2, A3, A4, A5, A6, then all I had to do was absolute value of array I minus 0. I didn't write minus 0. Okay, and add all these values into the answer, absolute of all these values into the answer, and that will be one possible answer. The next case is if n is equals to 4. Because for n equals to 4, we have a special case of 2 to 2. So I considered that case here. And then we know that if n was even, why I have written percentage 4 is because I have already multiplied n by 2 here. Okay. Since I want n should have been even, I'm checking if n is divisible by 4. If n is divisible by 4, then we have one more case, which is minus 1, minus 1, minus 1, minus 1, so on till, and the last value will be n by 2. We have this case as well. So I'm just trying to see if the difference from this case comes out to be minimum. So I do the same thing. I first take for the largest value, which is array n minus 1, because I've already sorted the entire array. I check for the largest value with n by 2, find the difference, and then for all the remaining values, I check the difference from minus 1. Then I try to see if this is the minimum possible answer, and then I just print the answer. That's all you had to do. So if you try to see, like, first it seems like this is a very bad problem. You just have to keep on thinking about how to find the sequence. But if you see, this is a very good algorithmic question, because all you had to do was write a brute force through which you could find out this approach. And then it was very easy. Okay. So that's all for problem C. I hope everybody is clear with this question. Okay, it was a good question, but yeah, there was a very nice trick to do this. And let's move on to problem E. I don't know, for some reason there are many less people watching, very less people watching. Maybe it's because of unusual timing. Anyways, let's move to problem E. Problem E is very simple. You're given a tree with n weighted vertices labeled from 1 to n, rooted at vertex 1. The parent of vertex I is P1 and the weight of vertex I is A1. For convenience, depth of P1 is 0. Okay, so basically you're given a tree rooted at 1. Okay, and every node actually has a weight. Now, for two vertices x and y of same depth, f of x is equals to, while x and y are not 0, make answer equal. Okay, let me just draw this one. So basically, let's say we had a small tree. Let's say this is the tree. We had 1, 2, 3, 4, 5. Let's say this is x, this is y, because x and y are from the same depth. Now our answer will actually become, answer will be ax into ay, which is the weight ax. So basically, what is ax? Ax is nothing but a4 times a5 plus, then x becomes parent of x. So basically x will go to 2, y will also go to 2. Then you will get a2 times a2. Again, this will go to parent, this will also go to parent. Then you will get a1 plus a1 times a1. And this is the entire answer for when x equals to 4 and y is equals to 5. Okay. Now, we have q number of queries. But for every query, we need to find the value of f of x and y. That's all. Okay. So again, this is a very easy problem. If you see, let me just try to draw this one. So what this is actually saying is n is equal to 6 and we are given two queries. Okay, now this is the weight, so I'll write the weight later. Let's draw the tree first. So root of 2 is 1, then root of 3 is 2, okay, then root of 4 is 3, root of 5 is also 3, and root of 6 is 2. And let me write the weights as well. Weight of this is 1, this is 5, this is 2, and then this is 3, this is 1, and this is 1. First query is for 4 and 5, for 4 and 5. For 4 and 5, right now since you are at 4 and 5, answer will be 3 into 1, 3 plus. Now go to the parent. Go to the parent, which is 2. So 2 times 2, what is happening? Yeah, 2 times 2 plus, again go to the parent, which is 5 times 5. Again go to the parent, which is 1 times 1. And this actually gives you 33. How do you really do this? If you see, all you're actually given is a huge tree okay. All you're given is just give me 1 second. There's some issue with my pencil. Okay. All you're given is a tree. Let's say this is the tree. Okay. And let's say this was x and this was y. First, you need to multiply weight of x by weight of y. Then go to the parent. Parent of this is this. Parent of this is this. Again multiply weight of this and this. Then again go to the parent. Go to the parent. This is the least common ancestor of these two values. So come till here and then everything is linear. Right. What if while I was calculating, I actually stored the value of, let's say like this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, 9, 10 and 11. Let's say while calculating the value of 8 and 11, so f of 8 comma 11 was nothing but weight of 8 times weight of 11 plus f of 4 and 5. Okay, what if I had already stored the value of 4 and 5? Similarly, like what is f of 4 and 5? F of 4 and 5 is nothing but weight of 4 times weight of 5 plus f of 2 and 2. What if I had the value of f of 2 and 2 already stored? Then it wouldn't be much of an operation. It will be very easy to find the answer. And that is exactly what you have to do. While finding the answer, let's say you have to find an answer for 8 and 11. When you find the answer of 4 and 5, just store this value. Exactly like Div. So that whenever this again, like this situation comes again, you just use the calculated value for this one as well. And that's all you have to do. Okay. But there is one thing. How do you really store this value? Okay, you cannot really use a map for this or an array for this because this is a two-dimensional value. You have x and y. So what you need to do is optimize this. And how do you like? So basically, the first way would have been you actually had a pair for int, comma int, and then you had an integer, and this is your map. Okay, but the problem is this becomes a two-dimensional map because there is a map in a map. A better way of doing this would be have a vector. Okay, have a vector, and in this vector have another unordered map of, let's say, int and int. Okay, and let's say this vector is v of size n. So when you actually find the answer for x comma y, what you will do is first see in the entire vector where your x is, and then for this x you will have an unordered map of key values where you will somewhere find y. And since it's an unordered map, the complexity for accessing this will be O of 1, and since it was a vector, again the complexity was O of 1. So in order to find the value of pre-calculated values, your complexity comes out to be O of 1 only, and that's all you have to do. Okay, let me show the code for this as well. I'll show you my code, which actually gave me a TLE. Okay, and then I'll show like what all optimization you have to do. So all I'm actually doing in this is first take all the weights, then all the parents, and then for every query, I'm just calling this function of solve x and y. What this entire like solve function is doing is, it is just checking if my x is equals to 0. If my x is equals to 0, that means I have reached the top of the tree. That means I don't need to do anything. Otherwise, I just check if this x comma y is already present in the map. If it is already present in the map, if it is not present, then calculate the value. Otherwise, just return. If it is not present, then multiply the weight of these two nodes and then call the same function again for the parent of these two nodes. That's all you have to do. But with this, you get a time TLE on test case 10. In order to like just solve this question, all you have to do is, instead of taking this map, you had to take this vector and then store all the values. If you had done this, you would have passed the cases, and that's all you had to do. Okay, so that's pretty much it for this one. I hope everybody enjoyed the stream and everybody knows how to solve problem A, B, C and E from this one. And yeah, that's pretty much it. We have a contest tomorrow as well, I think. Yeah, we have a div 4 contest. So I'll come live tomorrow as well. The contest is at 8 till 10:20. So I'll probably come live at 10:30 only. And yeah, that's pretty much it. Cool. Is there something else somebody wants to know from me, or else we can end the stream? I don't see any likes to the stream, only 14 likes. Do like the stream, guys. Cool. I think that's pretty much it. Let's meet tomorrow. Bye bye. Thank you for watching. Do subscribe to the channel as well.